What's up, guys? Today we're going to be going over limits. Kind of just the first thing you're really introduced to in any sort of calculus or pre-calculus class. Um, you know, Lots of people find these to be either the hardest thing or the easiest thing in calculus. I personally think that they're one of the easiest things about it, and that they don't really require that much intuition, which for me is where the majority of trouble comes from. Not really they're just pure math for the most part. So just like a little review about what exactly a limit is. Let's say I have the graph. It's not exactly what I'm looking for. Y equals x. If I have the limit of y equals x as x approaches, let's say 2 of x. What is this equal to? What is this entire thing equal to? Well, looking at this, you just plug it back into y equals x. So it's 2, because it's as x approaches 2, we just plug whatever number is in here into x. So it's 2 for this instance. If I wanted to do -2, the answer would be -2, because it's negative y equals -2. That's what it equals. That's what, as you go on either side, as you go towards x equals -2, you will come towards y equals -2. You see kind of like how it's like converging to this one point right here, and that this point is -2. That's essentially what a limit is depending on what it's converting to, what your x-axis is going to, it's basically what your y-axis is also going to at that point. So looking at this problem, just follow the same idea. It's going towards 2, 8 minus 3x plus 2x 12. So 8 minus 3 times 2, because you plug in 2 for x, plus 12 times 2 squared. So 8 minus 6 plus 12 times 4, 36. Nope, 48. 48. So 2 plus 40, that's an 8. 2 plus, that's whatever the hell that is. 2 plus 48 equals 50. So 50 is your answer here. Equals 50. Okay. Moving on. Get another problem. Limit as x approaches -3 t squared. Nope, not t squared. 6. Let's do 6 plus 4t. It's a 4, not an 8. Over t squared. What is that? Plus 1. Kind of the same idea. Once again, let me swap colors. 6 plus 4 times -3 over -3 squared plus 1. Now here is a thing that you kind of have to know about limits. Sometimes limits can, if a limit, not sometimes, if a limit ever equals 0 on the bottom, it doesn't exist. It's just you write DNE does not exist. This one, it doesn't equal 0 on the bottom here, so you just go ahead and solve this. So let's do that. 6 plus -12 is -6. The square goes, so it's 10, so it's -6 over 10. So that's essentially how you solve those sorts of problems. Other problems where the limit may equal 0 on the bottom, or on the top, or either way. If it equals 0 on the top and doesn't on the bottom, your answer is just 0, obviously. But when it equals 0 on both top and bottom, there are other things that you have to do in order to make it not do that. Because that doesn't show. The problem could very well be unsolvable. But you have to, if it's 0 over 0, you have to try. You have to make sure that it can work. So 3 to the 4th, let's see, that's 81 times 3, or 27 times 3 is 81. So 81 minus 81 over 2 to the, this is 9 times 18 minus 15 minus 3 over 0. So this is 0 over 0. So for those of you with a little bit of derivative calculus under your belt, or have taken Calculus 2, some classes teach us in Calculus 1. I think it's a Calculus 1 concept, but I know that it's taught at the end of it. So you may learn it until Calculus 2. But essentially, what you want to do, the easiest way to solve limits like this is you just take the derivative of the top and bottom. You don't do quotient rule. You just take derivative of top and bottom independently over 4x minus 5. You see I took the derivative of this portion, this x fourth to x to the fourth minus 81. 81 doesn't matter, so it's just 4x cubed using power rule. This 4x minus 5, obviously, and then you keep your limit, you bring it down. It doesn't change at all. Now you can plug it in. So you get 3 to the third over 4 to the 3, 4 times 3 minus 5. So 3 to the third is 27 times 4. I may have to whip out a calculator for this. 12 minus 5. Yeah, no. 4 times 27. Let me check on that real quick. I don't know these numbers off the top of my head, even though I should. 108. So this is equal to 108, and then this is equal to, what's that, 7? Can you divide 108 by 7? That's the real question. No, you can't. It's 15 point something, essentially. So yeah, that's the answer to this one. So this rule, where you take the derivative of the top and bottom, is called L'Hopital's rule. I think that's where the caret goes. Correct me if I'm wrong. It's called L'Hopital's rule. It's one of the most iconic rules in all of calculus. And it makes most like limits that would be tricky to solve because you'd have to simplify and simplify, especially ones that involving trig. They can be a real pain to simplify. It just makes them a joke, honestly. I remember in my calculus class, I learned about this like right as we started doing derivatives, because this was taught at the end of my calculus class. I learned about this when we started doing derivatives, and on the limits test, I literally got a 100 because all of the questions used L'Hopital's rule practically, and I was just able to finish the test in like 20 minutes, while other students were struggling. I ended up having to retake that test, and I'm kind of angry that I had to. So yeah, L'Hopital's rule. If you don't know it by now, it's and this isn't the first time you're hearing of it. It's pretty easy and it's very useful. Okay. I think, yikes. I think I'll do like one more. Let me check. Let's see if I can get a trig one. Okay. Limit. I don't know why there's that there. Okay, limit as x approaches, see, 0. Yeah, let's do a cosine one, and then I'll end off actually after this one with a sine one. E and like ln is you're not gonna really get those unless it's at like infinity or something like that. If you know what I'm saying. Like if it's not at like 0, 1, or infinity practically, because taking like ln of 5 is really like that's just some weird decimal number. It's not really like gonna tell you much for the most part. So ln of 0, 1, and infinity are going to be um, your values that you're going to see most often because they'll give you either, either 0 or e or whatever. Well, ln of 0 isn't a thing, I guess, but like you know what I'm saying. Okay. Um, cosine of 0 minus 1, or cosine of 0. So cosine of 0 is 1, obviously. If you didn't know that, you could say cosine x sine of x, and then unit circle 1, 0. So cosine has to be 1, sine is 0 at 0. 0 pi over 2, etc. Um, and so yeah, this is going to be 0 on the top. I can tell straight away that because the only difference between these two is a 2 here, and that's not going to matter with 0, that this equals 0 over 0. So I'm just going to go ahead and take the derivative. So sine of 2x, negative sine of 2x, times 2 is that top. Is that part at the top? Let me, like, net write this so it's not fucking horizontal. Sorry for swearing. Sine 2x over, yikes, over negative sine x, limit. Okay, so you want to plug in your limit, do it in a different color. Negative 2 times sine of 0, essentially, over negative sine of 0. You can't cancel these out, like don't cancel sine, because they have different things inside of them. Even though it won't matter because it's 0, you can't do that. You can cancel these negatives though. So 2 sine of 0 is 1, so it's just going to be 2 up on top and then 1 on the bottom. So your answer is 2. Once again, this one's pretty easy. Let me scroll over some more. Okay. Let's do this. No, I don't really want to do tangents. Let's do another trig one, because those are generally, like, in my experience, trig stuff is generally the hardest. Because, was it 3x? Yeah, trig stuff is generally the hardest just because it can be a bear to kind of simplify it all when you have to. For this one, you should notice that sine is going to be sine of 0, which is 1, so it's going to end up being 1 over 0. Now, in most cases, if this was not a sign up here, you would say, oh, it's undefined. If this was not a sign up here and this didn't approach 0, if this was limit as x approaches 1 of this thing, you would say it's undefined. It doesn't matter. Well, if it was a limit as x approaches 1, this wouldn't be 1 over 0. So I guess that's wrong, but yeah, if it wasn't sign up here, it wouldn't, this wouldn't be wrong. If it wasn't trig up here. So this would be undefined if it wasn't trig. So what I'm going to do is there is a very well-known sort of like formula, identity is the way I'd say, that limit as x approaches 0 of sine of x over x equals 1. There is a cosine version of this. I believe it's just cosine x over x equals 0. Let me check on that real quick, actually. I believe it's just cosine instead of sine. and it's everything else is the same. Um, it's one minus cosine x. So it's limit as x approaches 0 of 1 minus cosine x over x equals 0. These are kind of your holy grails when you don't have a problem that can do 0 over 0 or infinity over infinity for L'Hopital's rule. Another form to do of indeterminants is infinity over infinity in L'Hopital's rule. So that if you get 0 over 0 or infinity over infinity, and the problem doesn't look like it's like nearly impossible to differentiate, or it's like blatant, just use L'Hopital's rule and solve it that way. It's much faster and it's much easier, and it's much more likely that you're going to get the right answer if you know how to take a derivative. Um, so yeah, that's basically how we're going to solve this one. So I'm just going to take the 5 and the 3 sort of like out. So what it's going to be is it's going to be, well, I'm just going to multiply it by 5 over 5 because I want to be able to do this method. My bad, it should be 5x, not 15x. And then this becomes 3. So, never mind. I'll just do that, keep on doing that in another method, another step, so I can show you how this really works. So this is 3 right here. 3x. So, essentially what you're doing is you're just swapping these two. Limit as x approaches 0 of sine of 5x over 5x up here, sine of 5x times 5 over 3. Another, let me just put it like a caveat to this in a way. This could be anything. Whatever is inside the sine, if it's below here, it works. So if this is sine of 3x, this has to be 3x. If this is sine of 10x, this has to be 10x. This is sine of 552,605. This has to be 552,605x. It's whatever is inside the sine divided by what is inside the sine. Same thing with this cosine function. So this is going to equal 1. So it's going to be limit as x approaches 0 of 5 over 3 times 1, which you should know that there's no x, so it's just going to equal 5 over 3. And that's your answer. Have a good one, daddies.